Well, I guess spring has finally arrived and the weather has gotten better and I can actually go out in the garage and do things without freezing my ass off. So I have been plugging away at the 1930 Franklin here. This will probably be the first in a long series of video or vlogs or whatever they... Is that even a thing anymore? I don't know. But I just wanted to document some of the progress I'm doing on the car because there's not a lot of stuff about Franklins on, well, at least on YouTube. There's just a good amount of it on the internet at least, but not a lot of video of people actually working on the cars, which is kind of unfortunate, I think. Anyway, the goal today is to finish stripping the top end of the engine. I am not taking the cylinders off, but I am taking the heads and valve cages, push rod tubes, and all that off to get them clean. I'm going to be doing a valve lap job. They're pretty good. The seats that I've looked at so far are actually quite good. The engine has had minimal runtime. It's probably run once or twice before I got it. The carbon on the pistons wipes right off with a rag, for crying out loud, and the pistons are beautiful. I do need to remove some paint excess that wound up on the tops of the cylinders that has kind of cemented everything together. But mostly I'm just cleaning things up and redoing some of the gaskets. There are cork gaskets in the upper end here. There are copper gaskets, I'll show you, in between the head and cylinder that need to be annealed and then need to have graphite paste put on them for better thermal conductivity. That was not done, so taking it apart now and getting it done is a good thing. And having the top end of the engine stripped will allow me to look at perhaps putting a new coat of paint on the firewall, which is one thing I did want to do. I've dinged it a number of times during disassembly, and it's getting a little worn in places, and plus it wasn't painted up on the upper edge where the hood sits, and I want all that to match. So I want to get that done if I can, because with the hit down to the cylinder level, I can put plastic over everything, scuff all of this, and then I think Eastwood makes like a firewall paint. I think a few different vendors do. Just having a fresh coat of something a little more durable on here. This is pretty good, but I can scuff it and put a fresh coat of something on there because I'm probably not going to remove the body from the chassis anytime soon because the wood structure is not strong enough for me to bet on that all holding dimension right. So a little about the engine, first of all. This is a 1933 block. The car is a 1930, and I do have the original block from the car that is dated for 1930. Unfortunately, the previous owner discovered there was a crack in the generator base, which is actually part of the front end of the engine here, and so he didn't have the capability to get it fixed at the time. He got the car when he was like 19. So he set it aside, managed to find this 33, probably it was most likely a complete engine, and he swapped around some of the parts from the 30 engine and had the lower end line board, new bearings poured, insert bearings put in the connecting rods because originally they would have been Babbitt, and then basically built himself a complete unit using a mix of 33 and 30 parts. The upper end cylinders, cylinder heads, and valve cages appear to be 1930. Well, they are 1930, I know that for a fact. I'll try to explain why later. But the block, and I'm assuming the camshaft and crankshaft and all of the other moving assemblies are most likely from 33. I do have an extra crankshaft, probably the original. He said it was slightly bent in the middle and they were unable to correct that at a machine shop. So what I've got works. He went through all the trouble of weighing and balancing all of the connecting rods and pistons before putting it together, and checked the main rod bearing, or the main bearings with plastic gauge to make sure that it was correctly in spec, because these engines have slightly higher, lower tolerances than modern engines. They're a little looser. The Babbitt main bearings aren't supposed to be super tight. They need a decent amount of oil flow, oil volume, to keep them properly lubricated, so you don't want to get these super duper tight. But I know it runs decently. I've only run it a few times. I've driven the car around the block once or twice on last year, 4th of July actually. A lot of fun, sounds great, but it's nasty. And having done all this extra work to clean up the chassis, I don't want the engine to remain dirty, and there's a lot of baked on junk on the cylinder heads. Unfortunately, because of the way the oiling system works on this engine, the oil is inevitably going to wind up on the cylinder heads, and I'll bring you around and show you why that is. Okay, so here's the upper end of the engine valve train. There's a felt. So the Franklin engines, like most cars of the period that had separate heads and all of that that aren't force lubricated by the oil pump, have a felt pad that covers the rocker assembly. So one of these nice guys. These are actually made by the previous owner. They're in very good shape, and I just reused them. They soak up oil pretty nicely. You would hand oil those on the older engines every 400 miles or so, lay them over here, and then the oil just drips down. There are holes in the rockers that dropped into them. Of course, everything just kind of pools inside the top of the casting here, gets into the valves, etc., etc. Now, as you can see from this cylinder head over here, the assembly that mounts the rockers is not part of the cylinder head. Is a completely separate. I don't know if it's cast iron or cast steel, probably cast iron, and it simply attaches with 3 bolts. There are 3 studs here, here, and here. I've already got the nuts off of most of these. There's maybe some at the front that I haven't touched yet. That sits on here, and you notice the valves are kind of open around the bottom. There's a stack of cork that sits around these that gets sandwiched in between this surface and the bottom of this casting, and that's all that keeps the oil that winds up around the valve springs from just going all over the top of the head. As you can see, as soon as I took the valve cage off of this one, the excessive amount of Marvel Mystery oil that I had thrown in here has just oozed out all over everything. So it's pretty nasty. The engines do get dirty. That is the one thing that the club has pointed out to new owners of these cars, is that you can try to keep the engine clean. You can try, but that is not its natural state. It's going to get oil everywhere because the oil has nowhere else to go. It does not return to the crankcase once it has been used. It's either burned off or it leaks out, one or the other. Now, for all the previous engines, 1930 and earlier, that was the case. They changed something with the valve cage in 1931 and later that did allow oil to return to the crankcase. So if I bring you back just a little bit, you can see we've got our, I can't remember the names, our push rod tubes with a separate push rod inside. These are steel pipe, actually, with a decent wall thickness. Threaded on the top end, and then the bottom has a aluminum insert. I can show you. Well, I don't have one handy, sadly. Actually, no, I can. And there's one down here. I gently remove this. So there is our lifter, and we have an aluminum unit with a gasket on the bottom and a gasket on the top, crankcase side and pushrod tube side. This pops up inside the bottom of the pushrod tube and seats against it, and then there are a pair of brass bushings, maybe bronze, one at the top and one at the bottom of the tube, that hold the pushrod itself in line with everything. And that all has to pop off from there in order to get the cylinder head off, because these are so tight against things that the valve cage has to come off the cylinder head. These have to come off the cylinder head completely before you can get the head off the cylinder. And that's probably why Franklin recommends that the entire assembly comes off as a unit, and then you're supposed to undo the bolts to hold the head to the cylinder and then put a ram in through the bottom to pop them loose. I'm not going to do that because I found online an old article from the 70s from the Franklin Club describing how to remove these things with the engine still in the car. Now, their solution was to take a spark plug out and put some nylon rope on the inside and use the hand crank to put upward force to pop the cylinder head off the cylinder. I'm not doing that because I found that using a rubber hammer to tap on it gently works just as well, and my engine has been run so little that the two pieces have not welded themselves together yet. So there's that anyway. But the goal now is we got to get the valve cage off, and we got to get the push rod tubes out, and then we can free the nuts holding the head to the cylinder. And that's where it gets a little tricky because there are 6 nuts, and if we look over here at the pattern, you can see we've got 3 on one side, 3 at the other. Thankfully, there are none in between the cylinders. So in order to get to the nuts that are underneath here in this very narrow space between the cooling fins and the cylinder, we need an offset wrench. I just got these from Harbor Freight. Decent, works decent enough. They don't flex all that badly. Pretty good quality Indian wrenches. Anyway, so those are a necessity. I suppose you could also use a box end wrench with the end ground really thin, because there is not much space in there to get a wrench in. And plus, once you do these guys on the edge, you're fighting against the nut right next to it. So I started on number 1 and worked my way down, because working toward the firewall forward was not going to happen. So we need that. We also need a 7/8 socket and a 7/8 box wrench, which I do not have, unfortunately, because my wrench kit didn't come with one, to get the push rod tubes undone, because they are attached with a nut on the top and a nut on the bottom of the valve cage. The reason why they did this is because I said the oil gets captured in here and then just kind of drains out on top of the cylinder head. Well, the oil that pools around the 2 push rod tubes, there is a raised boss in the casting for each of these nuts, and underneath them is a copper crush washer to prevent the oil that builds up in here from leaking out and around things. While the tubes are hollow, Franklin recommended a lighter oil for the valve assemblies than what was used in the crankcase, and since the crankcase oil doesn't get pressurized up here, there's no reason for that oil to get dumped back inside. In 1931, they revamped the oiling system and made it pressure-fed from the crankcase. You can see there's a threaded hole in the back of the castings here. There's supposed to be a small copper pipe that comes up and over the felt pad and squirts oil on it. In 1930, they added a mechanical oiler that bolts onto the firewall and is operated through vibration of the chassis driving over unpaved roads, basically. They call it a shake and bake oiler. And that system would, in theory, provide just enough oil to keep the valves lubricated. According to the members, though, it's all or nothing. You either get not enough or you get way too much. And apparently even the later systems that came off the crankshaft weren't perfect either, so they recommend hand oiling the pads just for safety reasons, to keep everything from getting wiped out. So there would have been little copper T's on the ends here, chaining them all together, and they would have had restrictions in them so that the cylinder number 6 gets the same amount of oil, in theory, as cylinder number 1. Again, in practice, it wasn't perfect. It did kind of function. I do have the shake oiler for this. I'm going to put it back on. I'm not really going to use it. I'm just going to hand oil things, but it'll look neat. Anyway, in 1931, to go along with the pressurized oiling system, they got rid of this nut, and I think the lower one, and the valve cage assembly was redone to have threads in it. The raised boss that lives around these was eliminated and replaced with a concave tapered hole with threading inside of it, so the push rod tube, slightly shorter, would screw up into that, and the engine oil that was piped up to here would be allowed to trickle back through the top of that and into the crankcase, just like on a flat 4 VW engine. A lot of similarities between the designs. And you can retrofit those later heads to this engine, and in fact I think I might have a full set that would have originally been on this 33 block. But they're disgusting, and the valve seats in them, I don't know the condition. I know the valve seats in these are good. Well, actually, no, I think it's the valve cages. It doesn't really matter. I could swap them out. But I don't actually have, I don't think I have a full set of push rod tubes that are the correct length to screw up in these, because these come up way too high to be used in those. The threads are way too long. So the goal here is going to be to remove these nuts, get the valve cage off, and all that good stuff. Trouble is, I don't have a 7/8 wrench to get these nuts out, so my solution is to take the rockers out first, then I can use a 7/8 socket to pop these nuts off the top, and then I can take the valve cage off the head. In order to get the rockers out, there is a set screw and a lock nut here, which I just lost into the ether. Good thing I have spares. We're going to remove those and put them aside where I don't lose them. And then we're going to need to tap the hardened steel pin that holds that in there out with something vaguely resembling a punch. Close enough. Oh, That's the other thing. If any of these are actually being compressed currently, that's not going to work too well. I'll have to undo the set screw on the valve. Yeah, it'll throw off my valve lash, but that's easy to do. So once that pin comes out, rocker comes right off. Now these pins, you'll notice there's a hole bored through right here. There's this depression for the set screw. That hole is really important, and half the ones I've found in the car so far have been plugged. Each of the rockers has a pair of lubricating holes on it. One of them lubricates the top half of it. The other hole is supposed to allow oil to go through the pin and lubricate the bottom half of these brass inserts. And if those are plugged, that bottom half of the insert is going to get wiped out in rapid fashion. A lot of the ones I'm seeing and the extras that I have all appear to have a lot of gouging in the bottom there. They'll work, but eventually these inserts are going to need to be removed, and I'm going to have to machine new ones. But for now they function, and I'm going to clean out the lubricating port on all of these. There is some really packed in there dried oil. So that needs to be dealt with, or else you'll end up with burnt. Probably, I mean, they might actually seize. And if they seize, those are cast rockers, and I have been warned that if they're stuck, they can snap if they're forced against a stuck valve, so I don't really need to wind up breaking anything. So that one's out, and then let me crack this loose. There we go. Flathead screwdriver. I suppose I could roll the engine over, but I don't have the crank handy with me, unfortunately. We're just going to back this off. Now, there we go. Oh yeah, so rear valve is exhaust, front valve here is intake, and I am separating out the push rods and their lifters to make sure I don't lose their places. Some of these pins have been in there an awful long time and not too keen on coming out. I may have to knock this one out the opposite way. Yeah, a little more happy going out that direction. So I'll go ahead and we'll retrieve the intake push rod here. They also have these interesting little wings at the top. I'm not actually sure what that's for. I do know that these are, like most push rods, these are supposed to rotate in order to get even lubrication. I don't know if that's there to aid them or... Yeah. It's an interesting physical feature. Scoot that out all the way. There we go. Yeah, that one doesn't look too bad. Not a lot of messed up. Yeah, that port's plugged as well. Alright, so we're going to set that aside. I also make sure not to separate these from their valve casting, as I usually bag up the parts and put them aside. That one doesn't get lost. Okay, now the fun part. Getting the push rod tubes disconnected. So the push rod tubes have got these two nuts, one on top, one on bottom, obviously. However, they are also captured towards the crankcase by means of a small piece of metal. Let me get you further down to the surface here. So this little H-shaped, it's got a cut on either end with a nut on top of it. This is putting downward pressure on the bottoms of the push rod tubes. There's a flange on each one that slips over the aluminum lifter guide. So that's going to get torqued down, and that's going to hold these in place. I'm actually going to put a little bit of torque on that, just because these things want to spin when you try undoing the nuts, and sometimes I have to use a pair of vice grips gently on them. These are not thin wall. You're probably not going to crush them with light hand pressure if you need to put a bit of a grip on them. However, you do need to be careful taking tightening and loosening these nuts, you don't need to go gorilla strength with them. These look like studs. Same thing on the cylinders here. They got these double nuts on them. These are not studs. These are bolts threaded in from the bottom of the crankcase. There is threading in the block itself. They're screwed in from the bottom, and then there is a nut and washer that captures it and holds it in place, and then there's this nut up here. If that comes loose and you unscrew it, you need to drop the pan and somehow fish around behind, well, in this case, the camshaft and the crankshaft. And I think the cam has to be removed to get access to these because it's directly in line with all the lifters. So have fun with that. Same thing for the studs here. Those double nuts, those are there for a reason. Don't screw with them unless you know what you're doing, because if you back one of those out, pan's got to come off. You got to get around the crankshaft. And unlike most older cars, the Franklin uses a fully counterweighted crankshaft. And those counterweights are huge, and they are there's a pair of them on every single throw, and they get in the way real easy. So there's not a lot of room to get around in there. So unless you like lying on your back and staring at the insides of the engine, just use a little bit of caution there. So I put a little bit of pressure on that. We're going to come back up here, and I'm going to grab my 7/8 socket, and we're going to see if I can do this in one try. Probably not. Okay. I've also been trying to make sure to drain the oil out of these things because it makes a huge mess. And since this, oh, look at that. Yep, nope, almost. We almost had it. Oh well. The oil that is built up in these threads over the years and has been baked on, it is pretty nasty stuff. The nuts won't actually come off the lower section unless I throw these in a degreasing solution for over 24 hours. They're pretty nasty. But all this stuff is going to get cleaned. The push rod tubes and their holders are going to get repainted. It's all going to get fresh gaskets. And I will reuse the copper crush washers underneath the nuts. They just need to be annealed. There we go. And now the other side, probably the same story. Come on. Yeah, it's just going to rotate on us. All I'm doing is goofing up the paint that's already on there, not grabbing hard enough to bite into the... Well, good lord. Anyway. Nope, still need that. Ooh, this is going to be a nasty one to take off. I've been trying to drain the oil out of these or soak it up before I pull these off because it tends to make a run for it as soon as I break it loose from the head. All right, both of those. And since I still have the retainer on the bottom, all I need to do now is take off one nut over there. It should be 1/16. Nope, that is not a 9/16. What is that? 5/8. Thereabouts. There we go. Yeah, see? I'm already dinging up the firewall. Also going to be replacing every single one of these lock washers. No good reason to reuse split washers. Now we should be able to pop this sucker loose. There we go. Well, the oil's staying put for now, but it's not going to stick around for long. Now, kindly, someone actually used a punch and marked all the cylinder heads and all the valve cages 1 through 6. And then whoever put the engine back together ignored them completely and just mixed and matched them. So one of the things I intend to do is put them all back where they're supposed to be, otherwise it'll drive me nuts. You can see here. Jack the camera up. There we go. So there's our cork gaskets. I'm pretty sure this is supposed to be a one-piece affair, but I'm sure the previous owner had to make do with just... He made a lot of the gaskets himself. The copper gaskets look pretty good. I doubt they're original, but they're pretty good, and they aren't mangled, so I'm going to be reusing those. These, however, are completely compressed and aren't sealing worth a damn. So we're going to put those right in the bin. And you can see the some seriously nasty buildup on here. It's basically baked into the threads. So these lower nuts right here, I'm not even going to try to remove them, because the last time I did that, it started eating into the threads on the end and chewing them up. So I'm going to soak those in my ultrasonic cleaner, which has worked out really well, and then those should be nice and free. Okay, so we just need to take the nut off the bottom retainer here. Take off the little retaining cap. Now we should be able to just pull up on this, and that should slip right off. And I'm leaving the followers in place on the ladder because it plugs the hole in the block there. It keeps crap from getting in. Should have done that on the rest of them. And it keeps the followers in place. Alright, there we go. Now there is you can see there's still a gasket attached to the bottom of this one. And it's interesting, it actually flares out in this section here. Don't know why. There's that wonderful hardened sludge that's in there. These nuts won't even think of turning, so into the bath they go. And I'm using a ceramic-based high-temperature primer and paint that you can get at most auto parts stores. Okay, valve cage is off. Let's turn our attention back to cylinder number 4. And I'm going to try to pop the head off of it. Now, I have not undone the nuts on this side. Let me bring it down to see them. Okay, well, if you ignore the excessive amount of light that I've got overhead... Actually, I might be able to fix that. Alright, how's that? Okay, that's a bit better. Alright, so you can see our 3 nuts. We've got this one here, and this one here. You can see there's like a ½ inch between that nut and its neighbor, so an offset wrench like this is key to actually getting these out of there. These were put on with a little bit of oomph, so maybe do my damnedest not to hurt myself breaking these loose. Franklin did not publish any torque specs. These were, and even the instructions that I've read, basically just done by feel. So you snug them up until they're snug, and then that's kind of it. I mean, if you've seen the way Henry Ford's people put together Model T engines with T-handle wrenches on the main bearing caps, sure as hell weren't in torque specs. They just wrenched those suckers down until they stopped moving, and then went a little further. I'm only going to be able to get this so far down because the threads are longer, and we're going to wind up stopping right there. We won't be able to get that off until we pop the head up a little bit, and then I can finish unthreading them. Now we got to get this guy with the cylinder adjacent to it already taken apart. This is a lot simpler. Or it should be. So these other ones in here, you can't really get a straight shot on the nut. You kind of have to go at an angle, which makes it not quite so simple to get them loose. way to get that on there. I may have to cheat a little bit. Don't recommend doing this. But it does work when you need it to. There we go. Doing this also gives me an excuse to clean the rest of the crankcase because it's got a lot of really old oil still on it, although some of it's pretty recent from when I tried to getting this loose. I put Marvel Mystery Oil in all the cylinders thinking it was stuck, only to discover I simply hadn't put enough oomph into turning the starting crank, which then dumped all of the remaining oil out the spark plug holes and down the sides of the cylinders, and it still hasn't burnt all of it off yet. So I'm going to do what I can. You can see these 3 cylinders are pretty nasty. These 2 are pretty dry. This one's, yeah, it's a little icky. However, I'm going to leave the cylinders be. I don't have an appropriate valve spring compressor to put everything back together, and that's just... I have a problem with taking things apart. I don't need to take it any part further than this. Get this done. Put it all back together nicely with new gaskets, and then we should be golden. All right, got that side pretty well undone. Let me go check the other side. I don't remember if I took those nuts off yet. Yes. All right, we are totally off on that side, which means now we can apply a little bit of gentle force to pop the head loose. So I've got my rubber hammer, and since these cylinder head castings are aluminum, do not bang on the fins. I mean, don't bang on the fins and the steel cylinders either. But there are only 2 good places you can really hit this with any kind of force and not risk a lot of damage, and that's the underside of the exhaust manifold, the exhaust flange here, and this face up under where the front of the cylinder head and where the intake port is. So what I do is I alternate tapping on that and then going over and tapping on the other side and just rocking it back and forth. And that tends to... this one's a little more stuck than the previous 3. Hopefully I don't have to do anything too crazy. Okay, now I can see it does look like the gasket's trying to come along. Problem is, part of it's going to stick to the top of the cylinder. The other part is going to try hanging on to the threaded studs in the bottom of the cylinder head, and they're going to pull. I prefer to leave it behind on the cylinder head when I can. So I'm going to go around and I'm going to gently push on it and try to get it back down without gouging the mating surface. A pick would be a better tool for this. I don't have one handy. So I just try to gently, here we go, push that down against the surface. Ta-da! And there we go. Ooh, that piston is really clean. I'll bring you in and show you in just a second. Well, there we have it. Yeah, we have beheaded the cylinder. Try not to drop any small objects into it. And there's our missing capture screw, which I'm going to put on the valve cage before I forget it. There we are. And the combustion chamber themselves, they don't look too bad. I dunk these overnight in a degreasing solution, and then I do a light blast on the outside with very fine media and in the combustion chamber to clean everything up. And then we'll take the valve springs apart, take the valves out, clean up the guides, do a light lapping on the seats. And the soak will also remove a lot of this carbon buildup that's inside here. I got most of it out of the exhaust manifolds. The stuff that's on the inside of the heads, though, there is still pretty thick. So it'll get all that out. Alright, yeah, I can see in there. So here's piston number 1. I already wiped it off. You can still see the oversized stampings in there, or at least the original diameter. I think 50 thou was originally what they spec'd for them. Go in here with a paper towel and just like that. And someone has actually put punch marks, I just realized, on the top of the pistons to make sure they go back where they should. So this one, you just barely see it, has 4 prick marks right there. This guy has a single dirt-filled prick mark right there, and I think there are 2 on the top of this one. If I get some of the sludge off of it. Well, I'm just going to assume there are. My friend was somewhat meticulous with certain things. Well, there might be. Does this one have anything? Yes, it does. Right there. There are 3 little punch marks. Awesome. So these pistons are all in their original spots. The cylinders, though, I haven't found anything on the cylinders to indicate that they're in their correct spots. No 1, 2, 3 on the sealing surfaces or anything crazy. So no idea there. But that's all working pretty nicely. I'm going to go ahead and get the last 2 of these off, and then we're going to cover the top of this and start cleaning up all this junk. Apologies in advance for the lighting. I'm using a LED stand-up light because I don't have overhead in this section of the shop. So since I have all the heads off, I've already completely cleaned 2 of them, but I still need to do a little more work to those. I've got one currently in the vise flipped over because I was doing some valve lapping on them. But what I have done, and I'll grab this one. This is the one of my previous cleanups. This head right here has just come out of a 6-gallon bucket filled with a degreasing solution. It's a water-based guy. It does a pretty good job, but there's still some stuff on here that's very resilient. It's been baked on. I'm sure if I use something really caustic like Oven Off, it would probably do an even better job. But I don't really know how it'll react to aluminum. So I'm kind of leaving that be. And this head over here has had the bath done, but it has also been lightly sandblasted. Very, very, very fine grit media. I cover up the springs, but some stuff still does get under there, so I've been flushing everything out with brake clean or carburetor cleaner, and then I am taking the valves out and lapping the valves just to make sure everything is nice and clean, and then flushing out any debris that might still be in the ports, because I don't need any of the media winding up in the rings and ruining the cylinder walls. But as you can see, there's a well, it's kind of hard to see. There's a brass or bronze threaded insert for the spark plug, and then of course the valve seats, or the valve seats I believe are, I think they're bronze, or there's something similar to that. Actually, I can show you in the cylinder head that I've currently got up in the vise. It's not overly bright. You can actually see they look brass, bronzish. They might be bronze insert. I think they're bronze inserts, to be totally honest. Because I can see they're probably a good 1/4 of an inch thick. Starts in here and then it comes up. It's got to be a 1/4 of an inch thick insert. They're actually in really good shape. I did a few passes with each of them. This is the exhaust valve here. And the seats, they didn't take a whole lot. They cleaned up really nice. Same with the intake valve. There wasn't any real pitting or anything. The valve stems are still pretty nice. I need to get some more black oxide solution. The stuff that I have would not react on this, and I think I might have thrown away most of the active components of it. So I'll probably borrow some more of that from work, and then I will reinsert these into the head. I'll put them in there for now so I don't lose them, because I'm trying not to mix up any of the valves. So let me get this one off the vise here. And that's what the valve guides look like. Because the valves are on this area in here didn't get super clean, I went back with brushes and things, and once the valves are in there, it's not going to matter much. So I'm not going to worry a whole lot about everything being absolutely perfectly clean, because the valve cage is going to cover that whole region up, and I'm not going to be able to see it. So we're going to put just a little bit of light oil on the valve stems here, because I don't want to... I already scrubbed, I used a nylon brush and some solvent, and I scrubbed out the valve guides here. So I just want to make sure these are lubricated. There we go. That's better. And do the same here. I'll probably need to put, I think the tops of the guides are probably also black oxided, so might see if I can't put a little bit of fresh solution on that. If not, they're going to get totally coated in oil once they're in the engine and everything's working the way it should. Now, if you wanted to go really crazy with the valve lapping, you could put some acetone or something in here and see if it pools around, with the springs installed, obviously. If it pools around the valve, that means you got a really good seat. I'm not going to get that crazy with it. So I think for now, I'm just going to set this one aside. And we're going to make sure its springs stay with it. Oh yeah, these use a concentric spring design, if you hadn't noticed. So it drops in there. We have a retention cap that goes on top, and then the valve keepers, very, very basic. These valves don't use the little serrations like you see on a lot of newer cars. It's just a ground channel in the end of it. And I'll show you, we're going to take one of these apart here. If I get my light repositioned. So my friend who sold me the car very kindly provided me with a somewhat period-appropriate valve spring compressor. This wonderful crank-operated guy here. And this is actually really handy. I think it's got a bit of a... Let's see... Yeah, there's a latch mechanism built into the crank here, so that when it tightens up, it actually locks into place. Or at least it's supposed to. Yeah, I think once that's pushed in, it should... Yeah, it locks, and then you can pull that out of the way, and then it freewheels. So we're going to unscrew that all the way. flip that up like that, and then this makes it. This is. However, it's a little tricky doing it one way myself. So you gotta make sure everything's nice and lined up. There it goes. The gear is perhaps a bit small for this application. It's latched. I don't think we've compressed it enough. No, I think we have, actually. The keepers are falling out. Just need to snag them. There we go. Thankfully, all of these pieces are exactly the same. And we should be able to pull this. If I pull that back and let go of this, there we go. Not so bad. These springs are going to wind up taking a bath with the other parts in the ultrasonic cleaner because they've got junk on them. You want to see? Okay, yeah, the valves should be the springs should be the same height. If not, they're a tad compressed. All right, there we go. And there's that one. Yeah, as you can see, there's some junk living on the valve seat there that we need to get rid of. Interesting. This one still has manufacturer data on the stem. I figured some of these have been replaced. That one says Toledo, made USA. Very nice. S686. Interesting. Well, we need to give it a light love tap to. There. Pop out. Yeah, same story. A little dirty, but on the whole, not too bad. I do, however, take my light wire wheel and I take off some of this carbon buildup off the end of the stem, since it's... Or actually, no, most of this is probably exhaust. No, this is the intake valve, but yeah, there's some corrosion and junk on these. And I'll use a wire wheel to get that off. Same thing with that. Or actually, I might put them in the ultrason and just clean everything in one go. And then, of course, we need to get the rest of the junk living in and around here dealt with. This is one of the downsides of using a blast cabinet for stuff like this. It just winds up getting into all sorts of little nooks and crannies. Now, I could have taken the valves out and then blasted it. I hadn't planned on lapping them at the time. However, my fear was blasting the surfaces of the seats and kind of just ruining them. Same thing with the valve guides. Ultimately, it was just easier to tape off the springs from getting hit. And yeah, you can see the valve seat on that one. That was actually kind of shiny. See what we got here. Yeah, Yeah, valve seat on this guy still has a bit of shine to it. It's nice to see. No pitting. Of course, considering it's a non-ferrous metal, it's kind of hard to have pitting on it. It's probably why it survived, but these valves are also highly likely to be replacements. My friend was fairly meticulous when he did the engine, at least. However, one place my cabinet could not reach was inside and around that, so I'm going to take a brass brush and I'll try to scrub a lot of the loose stuff out of there, and then I can flush that out with carburetor cleaner or brake cleaner, what have you. And then we'll lap the valves. So to lap the valves, all I'm using is some conventional Permatex valve grinding paste. And I wound up going through 2 full cleanings. So I applied it, went in there, lapped it the first time, and then pulled it out, cleaned both the seat and valve surface, and applied paste for a second time, although it didn't really appear that the second go was necessary. Now, you notice I'm having some trouble with the suction cup style of valve tool. This is really all I had available, and these valves just don't have a smooth enough top surface to get the suction cup to stick, so I'm kind of just relying on friction. However, the results speak for themselves. I don't think I've seen a valve seat that even all the way around, and the valve surface was just as good. They started off good, not a lot of pitting in them, and yeah, I'm pretty happy with the way they turned out. Now the slot in the center of the valve is obviously for use with a screwdriver, or they did also make hand crank and electric drill powered valve tools, but I don't have one of those, sadly. Now the other thing I was told to do was to verify that the valve spring pressure required to actually open the valves was within spec, because if it's a little low, the valves might float at higher RPMs under load, and the engine won't perform as well. And I'm using an electronic scale here in my drill press to determine how much force is required to just get the valves to barely open, which it looks like the intake valve is about 39 pounds, and the exhaust valve here, I'm seeing about, well, not quite 45. That's a bit under spec. Franklin recommends 48 to 50 pounds on both. Now, since the valves on all of the heads I tested wound up being below the 48-pound minimum, I decided to shim them up, which was a recommendation of the club. And I thought I'd start by trying some generic washers from Lowe's. I believe these are 5/8 diameter washers, and they've got about a 1.35-ish OD. Now, I did wind up having to bore out the center a little bit on my mini lathe because there is a step at the bottom of the valve stem insert on the top that prevents it from seating flush. So that one there, I made it a little larger, about 720 thousandths, 0.72, in order to get it to fit. And we're going to reinstall the exhaust valve here and see if that improves the amount of force required to open it. Although I will say these washers are about 110 thousandths thick, which is a bit much. We want to be careful not to make it so that when the valve is compressed that the coils actually contact each other, which would completely negate their spring function. I'm also showing that the spring does have a specific orientation. The cluster of coils at the bottom that are close together needs to be towards the head rather than at the top. with the washer installed, we'll go back over to the scale and see how things pan out. Well, zeroing out the scale to take into account the weight of the head itself. Alright, so what we're seeing is we're getting a little over 60 pounds or so, 65, 60, almost up to 67, which is a bit outside of what the club members have recommended. So this washer is too thick, and I'm going to have to make something that's a little thinner. So since the original washer thickness of 110 thousandths was a bit too much, I estimated that about 60 or 70 thousandths might be more appropriate. This is the original 70 thousandths thick one that I machined with a outside diameter of about 1.33 inches and an ID of 720 versus some much nicer ones I had one of our CNC guys at work make. They're just using 4140 round stock, 1.5 inch diameter stuff. And I wound up putting these in all the heads, although I did do a test run on this first head here to verify that I had the right amount of pressure. I suspect I probably could have gone as low as 50 thousandths and still been within spec, but 70 I felt was a safer bet. Now it's hard to see, but ultimately it looks like we're getting a little bit above 60 psi or 60 pounds needed, maybe 61, 62 to open the get the valve to budge, which is perfectly acceptable to me and should work pretty good. And I think that's going to about wrap it up for this installment here. All of the spacers have been installed, all the valves have been lapped, a little bit of cleanup, and I went through and I put black oxide back on all of these studs, top and bottom, and oiled them for corrosion resistance. And I've been doing the same thing with all of the small hardware, all of the cylinder head nuts, valve cage nuts, etc., all getting the same treatment. In the next segment, it will be time to clean and anneal the copper head gaskets and get the heads installed. Anyway, thanks for sticking around for this one, and I will see you later. Thanks for watching.